So let us now start this new chapter called circles. You would have already studied circles in your 10th. You would know its definition. It is a collection of points which are equidistant from a fixed point. So in circle you have a fixed point, and then there are lots of points around this point which are at the same distance from this point. So all these pink points are at the same distance from the blue point. This blue point is called the center. The blue point is called the center, and the distance of every pink point, which is the same, is called the radius. Right? You would already know about this. So in this chapter we'll be studying this particular geometrical figure in a lot more detail. By now you would have already seen that every geometrical figure is just a collection of points. Every geometrical figure is just a collection of points. So all those points are obeying some condition, right? They're obeying some condition, and the collection of such points obeying a fixed condition is basically giving rise to a fixed shape. So this unique shape of a circle is subjected to the condition that all these points are at the same distance from this fixed point. So let us now look at the equation of a circle with center hk and radius r. So how do we find the equation of this? What we basically do is the center is hk, the radius is r, right? And this fixed point, let it be x comma y, right? So because this x comma y is basically at a distance r, all these pink points will be at the same distance r, right? So any of them can be your xy. I've just taken a random xy, right? And I will subject this xy to the condition that it has to be at a distance h comma k. It has to be at a distance r from h comma k. So the distance formula I will use between 2 points, between this point, and that should be equal to r. So x minus h square plus y minus k square is equals to r square. This is the equation of the circle, which has the center h comma k and has the radius r. So this h comma k is your center, and r is the radius. So I hope you are able to understand all the xy's which will obey this particular equation will be on the circle, and if you plot all those xy's, then what you will get is the set of these pink points. Basically these pink points is what you will get. They will all obey this condition. Let's move on to equation, the general equation of a circle. Let me introduce you to this new polynomial first of all. So this polynomial is called the general second degree polynomial. So what's so special about this? Why am I talking about this particular equation? As you can see, it has these weird terms: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. The thing about this polynomial is it represents every geometrical figure in your 2D geometry, right? So everything that we will study, circles, next we will study parabolas, next we will study ellipse, next we will study hyperbola, even the straight lines that you have studied, everything can be represented using this single equation. How is it possible? Well, different conditions. For example, if you want this equation to represent a straight line, then you will put a is equals to h is equals to b is equal to 0, right? If you put a, b and h 0, then this equation will reduce to 2gx plus 2fy plus c is equal to 0, which is your capital AX plus capital BY plus capital C form, right? It is in the similar form. So if I put different conditions on a, h, b, g, f, c, different conditions will give rise to different shapes. So let's see, when will this general second degree polynomial, remember this polynomial, it is extremely important, when will this polynomial act as a circle, or when will it represent a circle? That is the question. Well, to represent a circle, what are the conditions? Let's see the conditions on this particular general second degree equation. So here are your conditions. The first condition is this delta should not be 0. So in fact, this delta will be 0 only in case of pair of straight lines. So if your general second degree polynomial, if it represents a pair of straight lines, only then this quantity will be 0. For all other geometrical figures, it's not 0. So for circles also, obviously it's not 0. So this is the first condition. So you can remember this, the way my teacher taught it was, all hostel girls have boyfriends gone for cinema. So if you tell this to yourself, all hostel girls have boyfriends gone for cinema, you'll be able to remember this better. So this is your delta. The second condition is coefficient of x square should be equal to coefficient of y square. So this a should be equal to b. In fact, ideally it should be 1, right? It should be 1, because we will see the advantages if it is 1. So this is what your coefficient of x square equal to coefficient of y square. And the third condition is coefficient of xy should be 0. That means this h should be equal to 0. H should be equal to 0. The xy term should be missing, right? It shouldn't be there. If these three conditions are obeyed, I can say that this general second degree polynomial is representing a special shape, and that shape is your circle, right? So looking at this equation, what all can we say? Let's look at that. So I won't be deriving, but I would be stating the results. If you look at this equation, then the center of the circle can be straight away given by minus g comma minus f. This is your center. Remember, for this to be the center, so basically your coefficient of x, if it is 2g, then minus g is the center, right? So I can also say coefficient of x minus of that divided by 2 minus coefficient of y by 2. This can be your center, right? That is what it indirectly means. So whatever the coefficient of x is, put a negative sign against that and divide by 2. You'll get the x coordinate of center. Whatever the coefficient of y is, put a minus sign against it, divided by 2. You'll get the y coordinate of the center. So here you have the coordinates of center. Remember, these are the coordinates of center only if your x square and y square coefficients are 1. They have to be 1, right? Only then this will represent the center. Otherwise, if it is something like a 2, then you'll have to divide everything with 2, right? And then make sure that the coefficient of x square and y square is 1. So and then find the center, right? So remember, you can say that this minus g comma minus f is basically your center only if your x square and y square coefficients are 1. The second thing is, we can straight away say what is the radius of the circle. The formula for radius is g square plus f square minus c. Remember this is also very, very important. This is your radius. So if this is your circle, and obviously coefficient is 1. So remember, for all this, coefficient of x square and y square should be equal to 1. If that is obeyed, then this will be obeyed. Then we can say this also. So under root g square plus f square minus c is basically your radius. So these are two things. So ultimately, what more can I say? So this circle will be a point circle if g square plus f square minus c is equal to 0, right? If g square plus f square minus c is equal to 0, that means radius will be equal to 0, right? If radius is equal to 0, then that circle is, it is so small that it is almost equal to a point. So it is just a point circle. If g square plus f square minus c is greater than 0, then I will say, okay, a circle will exist, right? A small circle or a big circle will exist depending on what value this g square plus f square minus c is. But if your g square plus f square minus c is less than 0, then radius will be under root of something negative, right? It will be under root of something negative. So I will say circle will be, so if this condition is, if this is what is coming, then circle will be imaginary. So these are a few important points. So remember, this center formula and the radius formula is extremely crucial. So with this basic session on general equation of a circle done, let's move on to the next subtopic.